Welcome everybody to exercise 3 at the top of page 99 on the workbook. And this is another problem where we're given the graph of a function in just graphical form, no formula, and they'd like us to calculate some definite integrals. Okay, so let's work through these together. So starting with part A, they'd like us to calculate the integral from 0 to 2 of our function. Remember that definite integrals have to do with area. So area gets added if our function is above the x-axis and subtracted if it's below. So the area under our curve from 0 to 2, notice that the interval 0 to 2 is sitting here, so we've got some area that's above, but then there's a little bitty triangle of area that's down below. Okay, so what would the area overall be? Well, one thing that might help us with the calculation is to notice that that little triangle is kind of repeated once above and once below, so those two triangles are going to cancel each other. And so the net area that we're going to get from 0 to 2 is just the area of the square that we're seeing over here to the left, and we can see that that area is 1. Okay, so that should be our answer to part A. Okay, what about part B? Okay, well there, we're looking at the integral from 3 to 7. Okay, so let's maybe start by shading that area in our picture. So we're starting here and we're stopping here, and notice that that's the area of a semicircle. They tell us that in the problem. The question is, how do we find that area? Well, here it's helpful to think back to what the formula for the area of a circle is. I'm going to just write that down at the top of the page here. But remember, that formula pi r squared, that's the area of an entire circle, and we're just looking at the upper half of a circle. So we're going to get 1/2 of pi r squared, and then the only question remaining is, what is the radius of our circle? Well, you might notice that the center of the circle is at 5, and the radius would be this distance from 5 to 7 that I'm shading. So we've got a radius of 2, and again, because it's a half circle, we're going to get 1/2 pi times that radius of 2 squared. Okay, if you do the arithmetic there, that's going to be 1/2 of 4 pi, which is 2 pi. And so that should be our answer. That's the integral from 3 to 7. Okay, and moving on to C, the integral from 2 to 7. Okay, we've got a lot of drawing on our diagram, so I'm going to take a minute and just erase what was there before, so it's just a little easier to look at. Okay, so from 2 to 7, we're starting here at 2 and we're stopping here at 7, so we've got a little bit of area down below that's negative. Well, the area is not negative, but we're going to subtract it. And then we've got the area of the semicircle, which we already know is 2 pi from the calculation that we just did. So basically, all we need to do is to subtract the area of this triangle. You can maybe see from the picture that that's half of a square of area 1, so it should be -1/2, plus the area of the semicircle up here, which we already know is 2 pi. Okay, so we're going to get an answer that looks like 2 pi minus 1/2. You could get a decimal approximation for that if you wanted to. I'm going to leave it as just an exact number, 2 pi minus 1/2. Okay, and then we come to D. This, I think, is the hardest out of the 4 integrals that they asked us to do. Okay, so let's again just get rid of what we drew in the previous part and start fresh here. Okay, so what are we talking about when we talk about the integral from 5 to 8? Let's see if we can picture it first. Okay, so 5 gets us started here, and 8 is here. So we've got some area that's above the x-axis. That would be this region that we're looking at there. Okay, notice that that's part of the semicircle. So altogether, that would be 1/4 of a circle, but then we're subtracting some area below. You might have noticed that that region is very strangely shaped, and you might have looked at that and say, how do we find the area of something like that? Okay, well, I'm going to make a suggestion that might help. If we take that and just divide it into two pieces. I'm going to draw a vertical line here. Notice that that area below splits into a very tall, skinny triangle and then a rectangle. We can find the area of those two pieces separately and then come down with just one answer. So if we put all this together, let's start with the area above first. This was a quarter of a circle, so we're going to get 1/4 of pi r squared. Okay, that's the area above. Okay, then we need to subtract the area of this triangle. Okay, just this part from here to here. So what's the base and the height of that triangle? The base is just this tiny distance here from 7 to 7.5. So the base is 1/2. We're going to get 1/2 times 1/2. And then what's the height? Well, that's the vertical distance from here to here, which looks to be 2. Okay, I'm just going to remind you that where those numbers came from, base and height, we were subtracting the area of a triangle. Okay, and then finally, to finish this, we need to subtract the area of this tall, skinny rectangle between 7.5 and 8. Okay, and its area is just going to be its width of 1/2 times its height of 2. Okay, if we put all that together, that should give us our answer. Let's see what that works out to be. So 1/4 of pi times 2 squared, that's just going to be pi. 1/2 times 1/2 times 2. That's going to be a minus 1/2. And then over here on the right, 1/2 times 2 is 1. Put that all together, and it looks like we're going to get pi minus 3/2. And that should be our answer.